Hello, let us look at some review questions for the midterm in calculus. Alrighty, so here it goes. First one is about the limit. Y equals f of x, as you can see, it's right over here. And first one is limit of f of x as x approaches 1. This small negative sign means coming from the left. So 1 is over here, but I'm coming from the left. Then where does the graph approaching? It's going down. It's going down, so it's going to be negative infinity. How about the next one? Next one will be as x approaches 1 from the right side. Then 1 from the right side, you see the graph is going up all the way. So that means it's a positive infinity. How about as x approaches 1? You see when the left-sided limit and right-sided limit, when they don't agree, then we don't have the value for that limit do not exist. Let's look at the next one. How about the limit as x approaches negative 3? Negative 3 is right over here, even though there's a hole, but from the right side it's approaching 1, from the left side it's approaching 1. Both of them is approaching 1, therefore our answer is 1. How about as x approaches 3? 3 right over here. And from the left side it's approaching negative 1 here. Y value is negative 1. And then from the right side it's also approaching negative 1. So therefore, the answer is negative 1. Limit of f of x as x approaches negative infinity. So then, as I'm approaching negative infinity, that means I'm going this way, to the left. But I see the graph is going up, up, up. So therefore, it's going to be positive infinity. How about the limit as x approaches positive infinity? So from the sketch that I see, it seems like it's going down this way, but it seems like it's asymptotic about x equals negative and y equals negative 2. So therefore, the graph from this picture should be approaching negative 2 as you go to the right. Alright, so that's about it for number 1 through 7. Let's move on to the next question. Number 8. So we have to use the definition of derivative to evaluate or to find the to evaluate the limit, meaning find the derivative. So what are we going to do? First one is f of x plus h. So I'm going to plug in x plus h in place of x's. So here and then the here. Then f of x plus h would have been equal to 2 times x plus h squared minus 8 x plus h. Don't forget the parentheses here, and plus 5. Now, if I were to expand this one, don't forget x plus h is can be expressed as 2 times x squared plus 2 xh plus h squared. If I'll memorize this one because it's a rather popular expression. Minus 8x and then minus 8h plus 5. Now, I'm going to place this one in this location and then subtract f of x, which is the first one, and divide the entire thing by h. So then, limit, I'm going to now use a different color, limit as h approaches 0 for the first expression right over here. I'll be getting 2x squared and plus 4xh plus 2h squared, because I distributed 2 to all three terms, minus 8x minus 8h plus 5. That's the first portion right over here. And subtract f of x, that means the original function. Notice that I'm subtracting, so I have to distribute negative sign to all three terms. So we get minus 2x squared plus 8x minus 5. Divide the entire expression by h. Then you will notice that a few terms will cancel out. 2xh and then 8x and 5 as well. So in case of polynomial functions such as this one, after you cancel them out, all the terms should have h in it. That's the one way for you to check your work. Now then, if I have to rewrite this one, will be equal to limit as x approaches 0 for 4xh plus 2h squared minus 8h. And that's about it. Divide by h. Then you can see that h can cancel out here, and h squared now becomes h, just h by itself, and then this one cancels out. Now, and then as h approaching 0, so if I have to write it, limit of as h approaches 0, what remains here is we have 4x plus 2h minus 8. And as h approaches 0, this middle term will become 0, giving us 4x minus 8 as our final answer. And that is the derivative of this trinomial, as you can see. Alright, let's move on to the next question. Square root of 3x plus 1. So then, first of all, we have to realize what f of x plus h is. Then here we get square root of 3 times x plus h plus 1. Then same as before, limit as h approaches 0 for the first expression. So I'm going to have square root of 3x plus 3h plus 1 minus radical 3x plus 1 all over h. Now, so whenever I have radical, what do? You multiply top and bottom by its conjugate. So in other words, I have 2 actually I will just multiply this one top and bottom by its conjugate. That means it's going to be exactly the same expression, but this middle term, middle sign will be positive. So here we get square root of 3x plus 3h plus 1 plus 3x plus 1. I have to multiply this one top and bottom. Right over here. Now, once I do that, then what remains? That's equal to top is basically when you multiply 2 conjugates, then we're going to get difference of squares. Meaning first one is squared and difference, hence the subtraction sign, and second one will be squared as well. So we'll end up getting a limit as h approaches 0. We're going to have 3x plus 3h plus 1 and minus, subtracting these two terms, don't forget to distribute negative sign, 3x minus 1 all over h, and denominator is still carrying this expression. Now at this point you do not have to distribute h, just leave them alone because something's about to happen very soon. Now then we get to see that once again 3x cancels out and the 1 cancels out, then we have 3h left. So in other words, we have limit of 3h and then entire denominator. Denominator is still here, along with h as h approaches 0. Then you can see that h cancels out. We are left with 3 over that expression. Then limit as h approaches 0, 3 over that blue expression, as you can see. But you can see that as h approaches 0, only term that will become 0 is this portion. So as this term approaches 0, then we have 3x plus 1 and 3x plus 1. So our final answer becomes 3 over 2 times radical 3x plus 1 becomes our final answer. And then you can see that this one would have been the answer when you take the derivative of square root of 3x plus 1, including the chain rule. Alrighty, let's move on to the next question. Number 10. In this case, they want us to find the derivative of each of the following. So the first one, this before we do that, it will be quite it will be much easier if you had to convert everything into the numerical exponent. So here we get 5x and then plus 2 times x to the 1/3 power, that's what cube root is, minus 3 x to the negative 2 power because x squared was in the denominator. Now, but that's still equal to f of x. But what is f prime of x? Derivative. Then first term becomes 5. Second term 1/3 has to come to the front, so we get 2/3. 2 times 1/3 is 2/3. And x to the negative 2/3. Negative 2 has to come to the front, so making plus 6 x to the negative 3 power now because you have to subtract 1. And then if you have to clean this one up a little bit, we get 5. 2 is in the numerator. Because exponent is in the denominator, it's going to bring it down. So 3 times denominator of 3 makes it cube root. Numerator of the x makes it into, numerator of the exponent makes it into x squared here. And plus 6 over x cubed. So that's basically what we end up getting. Now, second question here we have sine square. So we have chain rule going on here. So if you have to look, remember this one is same thing as sine of 3x plus 1 quantity square. So these two essentially means the same thing. So our first layer has to be 2 coming to the front. So derivative of f of x is equal to 2. And then write down the entire expression to the first power, because by the chain rule 2 has to become 1. Then it's just the same thing as it is. So sine of 3x plus 1. Now second layer by the chain rule is the sine. What's the derivative of sine? It will be cosine. So I'm going to write down cosine of 3x plus 1. Notice that I have to carry the inside as they are. And my third layer becomes derivative of 3x plus 1, which is equal to 3. Then if I clean this one up just a little bit, I know that I can use the double angle formula for sine, but for now I'm just going to multiply 2 and 3. So we get 6 times sine of 3x plus 1 times cosine of 3x plus 1. That becomes our final answer. Now, let me do number 12 on the bottom. Outer layer was ln, natural log. So that means when I take the derivative of natural log, it becomes 1 over the expression. So we end up getting 1 over sine of x. And then inner layer is sine of x. So when you take the derivative of sine of x, then we get cosine of x. So this becomes cosine of x over sine of x. So that is correct answer, but if you go one step further, cosine over sine is cotangent. So many people might have just write it as cotangent of x as well. All right, let's look at the next question, number 13. Same deal, outer layer is ln, so I'm going to do 1 over square root of 2x plus 3. Now, derivative of square root of 2x plus 3 becomes, this one works like a 1/2 as an exponent, so I'm going to bring 1/2 down. And then 2x plus 3 to the negative 1/2 power, because 1/2 minus 1 becomes negative 1/2. By the chain rule, we have to multiply that by 2. Then you can see that this 2 cancels out with this 2. And if I have to rewrite it, then I will end up getting 1 over square root of 2x plus 3. But this negative 1/2 brings this one down, makes 2x plus 3 as well. Hence making our final answer as 1 over simply 2x plus 3. Because radical of the same kinds multiplied together becomes this. Now, number 14. We have to use the quotient rule. So then here we get f prime. We know that denominator becomes x squared of the square. So first I have to take the derivative of the top, which becomes 2 times e to the 2x times x squared. Multiply that by denominator. Now minus derivative of the bottom, which is 2x times e to the 2x. So if I were to just clean that up a little bit, I'll be getting 2x squared e to the 2x minus 2x e to the 2x over x to the 4th power. But if you want, you can divide by x because x is a common factor here. And this becomes 3, and this becomes 1. So our final answer could have been 2x e to the 2x minus 2 e to the 2x over x to the 3rd power. Of course, you could have factored out 2 times e to the 2x as well. Let's look at number 15 here. So we have a chain rule going on, but if I were to combine a cube and then 4th root, then we end up getting x squared plus 5x to the 3/4 power. This is a bit easier to look at. Then that's still f. So what is f prime? Then 3/4 comes to the front. And then we get x squared plus 5x, and I have to raise this one by negative 1/4 because subtracting 1 from 3/4. Multiply that by derivative of inside, which is 2x plus 5. Then if I were to rewrite this one, clean this one up a little bit, I'll be getting 3 times 2x plus 5 is on top, and then on the denominator we have 4 from here, and 4th root of x squared plus 5x. Right, that becomes our final answer. Alright, we'll continue later. I'll see you soon.